August 3rd, 1944. The midday sun beat down mercilessly on the flatlands surrounding Wichita, Kansas, as Hauptmann Ernst Becker stood at the entrance to what appeared to be the largest building he had ever seen. The structure stretched before him for what seemed like forever, its massive roof disappearing into the heat shimmer on the horizon. 4.2 million square feet of factory space under a single roof. The number meant nothing yet. It would. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Becker, a 34-year-old Luftwaffe pilot with 47 confirmed kills before his Fokker-Wulf had been shot down over Tunisia in May 1943, had spent the past 15 months as a prisoner of war in Camp Phillips, Kansas. He had adapted to captivity with the stoic pragmatism that characterized many German officers. The food was adequate, the barracks were heated. The Americans treated prisoners with a correctness that bordered on generosity compared to what he knew happened in German camps. But nothing in his 15 months of captivity had prepared him for what he was about to witness. Beside him stood 23 other German prisoners, mostly Luftwaffe officers, and a handful of Wehrmacht engineering specialists, all selected for this tour because of their technical backgrounds. Major Robert Harrison from Army Air Forces Intelligence stood at the front of the group, clipboard in hand, wearing the expression of a man about to deliver news he knew would be devastating. Harrison had organized this tour for a specific purpose. The Strategic Bombing Survey wanted German technical experts to understand what they were facing, not for propaganda, not for intimidation, but for the cold mathematical reality that the war was already over, decided not on battlefields but in places exactly like this factory that stretched before them into the Kansas heat. "Gentlemen," Harrison began, his voice carrying easily in the still air, "welcome to the Boeing Wichita plant. What you're about to see represents the future of aerial warfare and the reason why Germany cannot win this war." Becker exchanged glances with Oberleutnant Werner Vogel, a former engineering officer who had helped design components for the Bf-109. Both men had heard American boasts before. Both had dismissed them as propaganda. American equipment was adequate, they had been taught, but lacked the precision and technical excellence of German engineering. American industry was powerful but unsophisticated, producing quantity over quality. They were about to discover how catastrophically wrong those assumptions had been. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The numbers hit Becker before he entered the main facility. Harrison was reciting statistics with the casual confidence of a man who had delivered this briefing dozens of times, each number more staggering than the last. This facility employs 30,000 workers across 3 shifts, operating 24 hours a day, 7 days a week. At peak capacity, we're producing 4.2 B-29 Superfortress bombers every working day. That's roughly 100 aircraft per month from this single facility. Becker did the mental calculations automatically. 100 heavy bombers per month, 1,200 per year. From one factory, the Luftwaffe's entire production capacity, spread across dozens of facilities throughout Germany and occupied territories, produced perhaps 2,000 aircraft monthly of all types: fighters, bombers, reconnaissance planes, trainers, and most of those were single-engine fighters, nothing approaching the size or capability of whatever this B-29 was. The Boeing B-29 Superfortress, Harrison continued as they walked toward the entrance, represents the most advanced bomber ever constructed. Pressurized cabin allowing operations above 30,000 feet, 4 Wright R3000, 350 engines, each producing 2,200 horsepower. Remote-controlled defensive armament using analog computers for fire control. Maximum range of over 5,000 miles with a bomb load of 20,000 pounds. The specifications seemed impossible. Becker knew aircraft. He had flown the best fighters Germany produced. He understood the engineering challenges of high-altitude flight, the compromises required between range and payload, the complexity of remote weapons systems. What Harrison was describing shouldn't exist. The technology required hadn't been fully developed even in German research laboratories. They entered through massive loading doors designed to accommodate bomber fuselages. The temperature inside was brutally hot, easily over 100 degrees, with minimal ventilation despite the building's enormous volume. The smell hit them immediately, a mixture of paint, diesel fuel, hot metal, and sawdust. The noise was deafening, a constant industrial roar of rivet guns, power tools, diesel engines, and machinery operating at full capacity. But it was the sight that stopped all 24 prisoners in their tracks. The assembly line stretched before them further than they could see clearly, disappearing into the distance where heat, shimmer, and industrial haze made everything blur together. Not one aircraft, not 10, but dozens upon dozens of massive four-engine bombers in various stages of completion, arranged in precise rows that seemed to extend forever. "We use progressive assembly techniques," Harrison explained, his voice raised to carry over the industrial din. "The airframe moves through 42 distinct production stations. At each station, specialized crews perform specific tasks. Wings are attached, engines are mounted, electrical systems are installed, flight controls are fitted and tested. The entire process, from initial frame assembly to final inspection, takes approximately 3 weeks for each aircraft." Becker stood transfixed. He was watching industrial efficiency on a scale that made German production methods seem medieval by comparison. Workers, many of them women, moved with practiced efficiency between aircraft. Materials arrived exactly when and where needed, delivered by forklifts and overhead cranes in a choreographed dance of logistics that never paused. Every few minutes, another section of fuselage moved forward to the next station. The production line didn't stop for breaks, didn't pause for shift changes, didn't slow for any reason. It flowed like water, constant and inexorable, producing bombers with the same assembly line efficiency that Henry Ford had pioneered for automobiles decades earlier. "Impossible," Vogel whispered beside him in German. "No one can mass-produce heavy bombers like this. It can't be done." But Becker was watching it be done right in front of him. The evidence was overwhelming, undeniable, crushing in its implications. They moved closer to the production line, Harrison guiding them to an observation platform that overlooked the central assembly area. From this elevated vantage point, the full scale of the operation finally became visible, and what Becker saw made his stomach sink. 43 B-29 seconds in various stages of completion were visible from this single point. Some were just skeletal frames, with ribs and longerons forming the distinctive figure-8 cross-section of the pressurized fuselage. Others had their outer skin partially installed, aluminum sheets gleaming under the harsh electric lights. Further down the line, complete aircraft sat ready for engine installation, their wings extending outward in graceful curves that seemed impossibly long and thin. Near the end of the visible production line, finished aircraft underwent final systems checks. Becker could see technicians working inside open access panels, testing electrical systems, calibrating instruments, verifying that every one of the aircraft's hundreds of thousands of components functioned properly. The quality control was meticulous, every plane inspected repeatedly before it would be certified for combat operations. The B-29 contains approximately 450,000 individual parts, Harrison said, consulting his clipboard. 360,000 rivets in 550 different sizes. Total weight when fully loaded reaches 140,000 pounds. To put that in perspective, that's roughly equivalent to 70 automobiles. The comparisons were meaningless to Becker. He was trying to process the mathematics, the industrial implications of what he was witnessing. If this facility could produce 100 B-29 seconds monthly, and Harrison had mentioned there were multiple production facilities, then America was building hundreds of these massive bombers every month, possibly thousands over the course of a year. Germany's largest bomber, the He-177, had been produced in quantities of perhaps 1,000 total throughout the entire war. Most German bomber production focused on medium bombers like the Ju-88, aircraft with a fraction of the B-29's payload and range. And even those were being produced in numbers far smaller than what this single American factory achieved. How? Oberleutnant Franz Schmidt asked, his voice barely audible over the factory noise. Schmidt had managed logistics for a panzer division before his capture and understood supply chains and industrial coordination. How do you coordinate materials and components for this level of production? Harrison smiled, the expression of a teacher pleased that his student had asked the right question. That's the key innovation that makes this possible. We broke the construction process into modular sub-assemblies, manufactured at different locations, then brought together for final assembly here. He pointed to a wall-mounted diagram showing the supply chain. Wings are built in one section of the plant, fuselages in another, tail assemblies in a third section. Engines arrive from Wright Aeronautical in New Jersey, already tested and certified. Propellers come from Curtiss Electric in Ohio, instruments from various suppliers across 8 states, tires, hydraulic systems, oxygen equipment, machine guns, bomb racks, each component manufactured by specialized subcontractors, then delivered here exactly when needed for installation. Schmidt said quietly in German. They've systematized the entire production chain. More than that, Vogel added, also in German, they've created an integrated industrial network that functions like a single organism. When one factory increases production, all the supporting facilities automatically adjust their output to match. It's brilliant, and it means their production capacity can scale almost infinitely as long as they have raw materials and workers. Becker understood the implications, even if he didn't fully grasp the industrial engineering details. Germany's production was constrained by bottlenecks, by shortages of specific materials or components, by the need to repair bomb-damaged factories, by transportation systems that were increasingly disrupted by Allied air raids. American production was flowing smoothly, efficiently, protected by thousands of miles of ocean from any possible enemy attack. They descended from the observation platform and walked deeper into the facility. Harrison guided them through different sections, each one revealing another aspect of American industrial capacity that shattered German assumptions. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. In the wing assembly area, Becker watched workers construct the B-29's massive wings using techniques that seemed impossibly efficient. The wing measured 141 feet from tip to tip, the longest wingspan on any production bomber in the world. Yet the assembly process had been broken down into manageable steps that allowed relatively inexperienced workers to complete complex tasks with minimal error. Wing construction typically requires the most skilled workers, Harrison explained. Tolerances are measured in thousandths of an inch. Any mistakes in alignment or stress distribution can cause catastrophic failure during flight. We solved this problem through precision jigs and fixtures that hold components in exact position during assembly. A worker with 2 weeks of training can now perform tasks that previously required years of apprenticeship. The jigs were enormous steel structures, precisely machined to hold wing ribs, spars, and skin panels in perfect alignment. Workers would position components into the jig, verify alignment with measuring tools, then rivet or bolt everything together. The jig ensured accuracy, transforming aircraft construction from an art requiring master craftsmen into a systematic process that could be taught quickly and repeated identically thousands of times. How many of your workers had aircraft experience before the war? Becker asked through the translator. Less than 5%, Harrison replied without hesitation. Most learned their skills on the job over a period of weeks. We hire anyone capable of learning the work. Women, older men who couldn't serve in the military, even teenagers. The only requirement is willingness to work hard and ability to follow instructions precisely. Becker looked around at the workers visible from their position. Harrison was right. A significant percentage were women, many appearing to be in their 20s or 30s. They operated welding equipment, drove forklifts, read technical diagrams, and performed quality control inspections with the same competence as their male counterparts. The contrast with German industry was stark. Nazi ideology had explicitly excluded women from industrial work, insisting they belonged in the home raising children for the Reich. This decision, made for ideological reasons rather than practical ones, had cut Germany's potential workforce in half. America had no such restrictions. When war created labor shortages, American factories hired women and trained them to do whatever needed doing. "We're wasting half our population," Vogel said quietly in German, echoing Becker's thoughts, "while they're using everyone capable of work regardless of gender. The inefficiency is criminal." They moved to the engine installation section. 4 Right R. 3,350 engines sat on wheeled dollies, each one a massive radial engine with 18 cylinders arranged in 2 rows, producing 2,200 horsepower at full throttle. Workers were preparing to install these engines onto a B-29 that had just received its completed wings. Engine installation takes approximately 4 hours for all 4 engines, Harrison said. The engines arrive fully tested and certified. We mount them to the wing using standardized attachment points, connect fuel lines, electrical systems, and control linkages, then perform a systems check. If everything tests properly, that aircraft is 1 step closer to completion. Becker watched the installation process with growing comprehension of what made American production so efficient. Everything was standardized. Every B-29 used identical engine mounts, identical electrical connectors, identical fuel line fittings. Parts were interchangeable between aircraft. Maintenance procedures could be documented and followed by any trained technician. There was no need for custom fitting or hand adjustment. German aircraft production still relied heavily on skilled craftsmen who fitted components individually to each airframe. This produced aircraft of exceptional quality when everything went right, but it was slow, expensive, and impossible to scale to mass production levels. American methods sacrificed some of that artisan precision in favor of standardization and volume. The trade-off was obvious. One exceptional German aircraft might be superior to one American aircraft in specific performance metrics, but when America could produce 10 aircraft for every one Germany built, that individual superiority became meaningless. They reached the most impressive section of the facility, final assembly and testing. Here, completed B-29 seconds underwent comprehensive systems checks before being certified for delivery to operational units. Test pilots would perform ground runs, checking that all 4 engines operated properly, that flight controls moved correctly, that pressurization systems maintained cabin pressure. "We deliver 100 aircraft monthly from this facility," Harrison repeated. Boeing operates additional B-29 production lines at Renton, Washington. Bell Aircraft builds them at Marietta, Georgia. Martin Aircraft produces them at Omaha, Nebraska. Combined production across all 4 facilities currently exceeds 300 B-29 seconds monthly, with production still ramping up. By year's end, we expect to be delivering over 400 Superfortresses per month. 400 heavy bombers, monthly. 4,800 annually. Becker forced himself to process these numbers, to accept their reality despite how impossible they seemed. The Luftwaffe had approximately 2,200 fighters available for defense of the Reich, according to the last briefings Becker had received before his capture over a year ago. Those fighters had to defend against both American daylight bombing raids and British nighttime attacks. Every month, America would be adding more heavy bombers to their force than Germany had fighters available for all defensive operations combined. And these weren't just any bombers. The B-29 could fly higher than German fighters could effectively intercept. It could strike targets deep inside Germany, then return to bases in England or Italy without refueling. It carried defensive armament, that would make interception dangerous, even for successful fighter attacks. And it could deliver bomb loads that would devastate any target it reached. "Your Luftwaffe cannot stop these aircraft," Harrison said bluntly, reading Becker's expression correctly. "Your fighters lack the performance to intercept effectively at 30,000 feet. Your anti-aircraft artillery can't reach these altitudes reliably. And even if you could engage them, we're building them faster than you can destroy them. This isn't warfare anymore, Hauptmann Becker. This is mathematics, and the mathematics are not in Germany's favour." The statistics board, mounted on the wall near final assembly, told a story more devastating than any battlefield defeat. Harrison paused before it, allowing the German prisoners time to absorb what they were seeing. July 1944, 680,000 tons of aluminum processed. August, 710,000 tons projected, monthly production averaging well over 500,000 tons from American smelters, with capacity still expanding. Becker stared at the numbers, doing calculations he wished he didn't have to do. Germany's total aluminum production, even including occupied territories and captured facilities, reached perhaps 250,000 tons annually in a good year. America was producing that much every 6 weeks. Just in aluminum alone, the raw material essential for aircraft construction, America possessed a 4-to-1 advantage before a single plane was even designed. "Where does it all come from?" Oberleutnant Karl Hoffmann asked, his voice carrying a note of desperation. Hoffmann had worked in industrial planning for the Reich Ministry of Armaments before his conscription. He understood resource economics. The aluminum, the steel, the copper, the rubber. How do you source materials on this scale? Harrison pulled out a folder containing maps and production data. Aluminum comes from smelters in the Pacific Northwest, powered by hydroelectric dams on the Columbia River. Iron ore arrives from Minnesota's Mesabi Range via Great Lakes shipping, coal from Pennsylvania and West Virginia by rail, copper from mines in Montana, Arizona, and Utah, rubber plantations in Liberia, supplemented by synthetic rubber plants in Texas and Louisiana. He traced supply routes on the map with his finger. "Understand, gentlemen, the continental United States spans roughly 3,000 miles east to west, 1,500 miles north to south. We possess abundant deposits of virtually every strategic material required for modern warfare, all located within borders protected by 2 oceans. There are no supply lines for enemy submarines to cut, no rail networks for enemy bombers to destroy, no convoy routes requiring naval protection." The geography lesson was devastating in its simplicity. Germany was fighting a war of attrition against an enemy that couldn't be attacked at its source of strength. Every German factory was vulnerable to Allied bombing. Every German rail line could be disrupted. Every German port risked blockade. American industry operated in complete safety, thousands of miles from any possible threat, with internal transportation networks that couldn't be interdicted. "We never had a chance," Schmidt said quietly in German. "From the moment America entered the war, the outcome was decided. We just didn't know it yet." Harrison heard the tone even if he didn't understand the words. "Your nation made a fundamental strategic error," he said through the translator. "Germany assumed American industrial capacity was exaggerated, that our production methods were inefficient, that our equipment was inferior. Every one of those assumptions was wrong. American industry isn't just larger than German industry. It's more efficient, more flexible, more technologically advanced, and completely invulnerable to attack." They moved to another section where workers were installing the B-29's revolutionary defensive armament system. Becker recognized immediately that this was technology Germany had attempted but never successfully implemented. "The Central Fire Control System," Harrison explained, "represents one of the most significant innovations in bomber design. 4 remote-controlled turrets, 2 dorsal and 2 ventral, plus a manned tail position. Each turret contains either 2 or 4 50 caliber machine guns. Total defensive armament, 12 machine guns." That alone was impressive, but Becker knew most bombers carried similar armament. What made this different was what Harrison said next. Gunners don't sit in the turrets. They sit in pressurized compartments, comfortable and protected, using computing gun sights, connected to analog computers. The gunner tracks the target visually. The computer calculates lead angles accounting for aircraft speed, target speed, altitude, and ballistics. Then the computer automatically aims the turret and fires the guns. One gunner can control multiple turrets simultaneously. If one gunner is wounded, another can instantly take control of his turrets. Vogel stepped closer to examine the turret mechanism visible on a partially completed aircraft. The engineering was sophisticated, with electric motors for turret rotation and elevation, mechanical linkages for the computing site, and electrical switching systems for gunner control. This was the kind of technology German engineers had been developing in laboratories, but had never successfully translated into production aircraft. The Luftwaffe experimented with remote turrets, Vogel said in German to Becker. We couldn't make them reliable enough for combat use. The electrical systems failed. The mechanical linkages jammed. The computing systems couldn't handle the calculations quickly enough. How did they solve problems we couldn't? Investment, Becker replied, also in German, and time. They started developing this years before the war began, using resources we never committed. By the time we recognized the need, they had already perfected the technology and put it into production. Harrison was explaining the system's capabilities to another prisoner when an alarm sounded, 3 short blasts that echoed through the enormous factory space. Immediately, workers began securing their stations, shutting down equipment that couldn't safely be left running and moving toward marked assembly areas. Shift change, Harrison explained. The day shift ends at 4 p.m. Evening shift begins at 4:30. We have a 30-minute overlap for briefings and handoffs. Watch carefully. This is another reason why American production is so efficient. Becker observed as hundreds of workers moved through the factory in an orderly flow. Day shift workers filed toward exits, while evening shift workers entered through separate doors and moved to their assigned stations. Supervisors met briefly with their counterparts, reviewing status reports and noting any issues requiring attention. The transition was smooth, practiced, efficient. Within 20 minutes, the evening shift had assumed full control of all production stations. Equipment powered up. Work resumed. The production line continued its inexorable forward motion without pause or delay. 72 production hours per day, 3 shifts of 2,400 workers each, Harrison said. The factory literally never stops. Christmas, New Year's, weekends, it makes no difference. As long as materials and workers are available, bombers come off this line every few hours, day after day, month after month, until we have enough to win the war. They walked past a section where recently completed B-29 seconds sat in neat rows, awaiting final acceptance inspections before delivery to operational units. Becker counted 37 aircraft visible from this position, all finished, all ready for combat, representing more heavy bomber capacity than some entire Luftwaffe bomber wings. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological impact was crushing. Becker had spent 15 months in captivity, clinging to hope that Germany might still achieve a negotiated peace, that some combination of new weapons and tactical brilliance might turn the tide. Standing here in this cathedral of American industrial power, watching bombers roll off assembly lines like automobiles, that hope evaporated like morning dew under the Kansas sun. How many of these facilities does America operate? Becker asked, though he dreaded the answer. Harrison consulted his clipboard. For B-29 production specifically, 4 main assembly plants, as I mentioned. But for all aircraft types combined, the United States operates over 300 major production facilities, plus thousands of subcontractors manufacturing components. Total American aircraft production for 1944 will exceed 96,000 aircraft of all types. 96,000 aircraft in a single year. The number was so large it became almost meaningless, impossible to visualize or comprehend. Germany and all occupied territories combined might produce 25,000 aircraft in 1944 if everything went perfectly. If Allied bombing didn't disrupt production worse than it already had, if raw materials remained available, if skilled workers could be found. America was outproducing Germany nearly 4-1 in aircraft alone, and those American aircraft were on average larger, more capable, and more reliable than their German counterparts. The B-29 Flying Fortress, Harrison continued, warming to his subject, has been in production since 1941. Total production to date exceeds 12,000 aircraft. The B-24 Liberator, nearly 19,000 produced. The P-47 Thunderbolt fighter, over 15,000. The P-51 Mustang, production accelerating toward 10,000 annually. These aren't prototypes or limited production runs. These are mass-produced weapons rolling off assembly lines in numbers that would have seemed impossible just a few years ago. They reached a large conference room adjacent to the factory floor, where Harrison had arranged a briefing on strategic bombing doctrine and American production capacity. The German prisoners sat gratefully in comfortable chairs, while Harrison dimmed the lights and started a slide projector. The first slide showed a map of the United States with major production facilities marked. Aircraft factories in Washington, Kansas, Georgia, Nebraska, and California. Shipyards in Virginia, California, Texas, and Massachusetts. Steel mills in Pennsylvania, Ohio, Indiana, and Alabama. Tank factories in Michigan and Ohio. The map was covered with symbols, each one representing a facility producing military equipment. The United States has mobilized its entire industrial economy for war production, Harrison explained. Automobile manufacturers stopped building cars and started building tanks, aircraft, and military vehicles. Appliance manufacturers now produce ammunition and artillery shells. Textile mills make uniforms and parachutes. Every major industry has converted partially or completely to military production while still maintaining enough civilian production to support the home front. The next slide showed production statistics that made Becker's head swim. American steel production, 90 million tons annually. German production, including occupied territories, 30 million tons. American tank production, 29,000 in 1943 alone. German production, 12,000. American military trucks, 600,000. German production, 90,000. The disparities were consistent across every category. America outproduced Germany by factors of 2-1, 3-1, sometimes 5-1 or more, and American production was accelerating while German production was declining due to strategic bombing, raw material shortages, and labor problems. Your nation cannot win a war of industrial attrition against the United States, Harrison said bluntly. The mathematics are absolute. For every tank you build, we build 2 or 3. For every aircraft you produce, we produce 4. For every ton of ammunition you manufacture, we manufacture 5 tons. The longer this war continues, the worse the disparity becomes. A hand went up. Hauptmann Friedrich Weber, a decorated veteran of the Eastern Front who had been captured during the Tunisia campaign, asked, the question everyone was thinking, "Why are you showing us this? What purpose does it serve to demonstrate our defeat so thoroughly?" Harrison's expression softened slightly. "Because we want you to understand reality, Hauptmann. Your government has fed you lies about American weakness, about our industrial inability, about the inevitable triumph of German arms. Every one of those claims was propaganda designed to maintain morale. The truth is that Germany never had sufficient industrial capacity to fight a prolonged war against the combined Allied powers. This facility alone produces more heavy bombers monthly than your entire aircraft industry produces bombers of all types. He advanced to the next slide, showing a B-29 inches flight, its sleek lines unmistakable against a clear blue sky. This aircraft represents the future of strategic bombing. It can strike any target in Germany from bases in England or Italy. Your fighters cannot intercept it effectively. Your anti-aircraft, artillery cannot reach it reliably. And we're building 400 of them every month. Within 6 months, we'll have an unstoppable strategic bombing force, capable of systematically destroying every remaining German industrial facility. The room fell silent. The implications were inescapable. Germany faced an enemy that could attack with impunity, that possessed unlimited resources, that could replace losses faster than they could be inflicted. Tactical brilliance, operational flexibility, even individual weapon superiority meant nothing against such overwhelming material advantage. Vogel raised his hand. If the outcome is so certain, why continue fighting? Why not end the war now and spare both sides further casualties? Harrison's expression turned grim. That's a question for politicians, not soldiers. From a purely military perspective, yes, Germany has already lost, but your government continues to fight, continues to sacrifice German soldiers and civilians in a war that cannot be won. Every month of continued resistance means more cities bombed, more soldiers killed, more destruction of what little industrial capacity Germany has remaining. He paused, then added more quietly, "We hope that men like you, German officers who understand the reality of the situation, will help rebuild Germany after the war ends. We hope you'll take these lessons back home and ensure Germany never again makes the mistake of starting a war it cannot win. That's why we're showing you this. Not to humiliate you, but to educate you about what actually determines the outcome of modern industrial warfare." The briefing continued for another hour, covering American production statistics, supply chain logistics, workforce training programs, and strategic bombing doctrine. Every slide reinforced the same message. American industrial capacity exceeded German capacity by such enormous margins that continued resistance was futile. As daylight faded outside and the factory floor, lights blazed on for the evening shift. Harrison led the prisoners back through the production areas one final time. Becker noticed things he had missed during the initial tour: the attention to safety equipment, with fire extinguishers and first aid stations positioned throughout the facility; the quality control inspectors checking components at every stage of production; the maintenance crews keeping equipment running smoothly; the material handlers ensuring parts arrived exactly when needed. Every aspect of the operation had been optimized through months or years of refinement. This wasn't improvised wartime production. This was systematic industrial engineering applied at massive scale, representing decades of American experience with mass manufacturing techniques. They paused at the final inspection area, where completed B-29 seconds received acceptance flights. A bomber was being prepared for its maiden voyage, engines warming up with that distinctive roar of 4 massive radials, operating in symphony. Test pilots conducted pre-flight checks while ground crews verified that every system functioned properly. That aircraft, Harrison said, pointing to the B-29 being readied for flight, was started 3 weeks ago as components on various production lines. Now it's a complete combat-ready bomber that will be delivered to an operational unit within 48 hours. 3 weeks from raw materials to finished weapon. That's American industrial capacity. The bomber began taxiing toward the runway, its massive bulk moving with surprising grace. Becker watched it depart, watched it lift into the darkening Kansas sky, watched its navigation lights disappear into the distance. Somewhere over Germany, bombers just like that one were dropping tons of high explosives on cities and industrial targets. Every night, British bombers. Every day, American bombers. The attacks never stopped, never paused, never gave German defenders time to recover. And every month, America added hundreds more bombers to the fleet while German production declined. The mathematical inevitability of defeat was absolute. The transport trucks returned the prisoners to Camp Phillips as full darkness settled over Kansas. Becker sat in silence during the 30-minute drive, processing what he had witnessed. The other prisoners were equally quiet, each man lost in his own thoughts about the implications of what they had seen. Back at the camp, in the barracks they shared, the prisoners gathered to discuss the day's revelations. The conversation was conducted entirely in German, without guards present, allowing for complete honesty. "We lost this war before it began," Weber said flatly. "If American production capacity is even half of what they showed us today, Germany never had a realistic chance of victory. We were fighting an enemy that possessed every possible advantage: resources, geography, industrial capacity, technological innovation, everything." Schmidt agreed. "The strategic bombing campaign makes sense now. They're not trying to win the war through bombing alone. They're destroying German industrial capacity so thoroughly that even if some negotiated peace were possible, Germany would emerge completely unable to threaten anyone for decades. They're systematically dismantling our ability to wage war." "What happens when the war ends?" Hoffman asked. "Do we return to a Germany that no longer exists? Every major city bombed into ruins, industry destroyed, transportation systems wrecked, millions dead. What kind of nation will we be rebuilding?" Becker had been thinking about that question since the moment he realized Germany's defeat was inevitable. "We rebuild from nothing," he said quietly. "We start over, this time without the insane ideology that led us into this disaster. We build a Germany based on economic prosperity instead of military conquest, on cooperation with neighbors instead of domination, on reality instead of propaganda." Vogel laughed bitterly. "Assuming the Allies allow us to rebuild at all, they might decide Germany is too dangerous to ever permit recovery, partition us, occupy us permanently, reduce us to an agricultural society incapable of threatening anyone." "They won't," Becker said with more confidence than he felt. "America demonstrated today that they're not driven by revenge or hatred. They're pragmatic. They'll want a stable Germany that can serve as a trading partner and bulwark against Soviet expansion. The question is whether we German officers are willing to help build that new Germany, or whether we cling to the old ideologies that brought us to defeat." The conversation continued, late into the night, German officers wrestling with the implications of what they had witnessed. They had seen the future, and it was a future where Germany existed only at the sufferance of powers that possessed industrial capacity beyond anything the Reich had ever achieved or could hope to achieve. August 5th, 1944. 2 days after the Wichita tour, Major Harrison arranged for a smaller group of German prisoners to visit a different facility. This one focused on engine production. The Wright Aeronautical Plant in Kansas produced the R-3350 engines that powered the B-29, and Harrison wanted the Germans to understand that aircraft production was supported by equally impressive engine manufacturing capacity. The engine plant employed 12,000 workers, producing the massive 18-cylinder engines at a rate of 400 per month. Each engine required thousands of precisely machined parts, manufactured to tolerances, measured in thousandths of an inch. Crankshafts, cylinder heads, pistons, connecting rods, valve assemblies, every component manufactured with precision that would have impressed German engineers if it weren't so devastating to contemplate. "Engine production is the bottleneck for aircraft manufacturing," Harrison explained as they walked through the dime facility. "You can assemble airframes relatively quickly, but engines require precision manufacturing that takes time. That's why we've invested heavily in engine production capacity, building facilities specifically designed for mass production of aircraft engines." Becker watched workers assembling engines with the same systematic efficiency he had seen at the Boeing plant. Components arrived from machining stations, were inspected for quality, then installed onto engine blocks following documented procedures that ensured consistency and reliability. "Each engine is test run for 12 hours before shipment," Harrison continued. "We verify that it produces rated horsepower at various throttle settings, that cooling systems function properly, that oil pressure and temperature remain within specifications. that no components fail under operational stress. Only engines that pass all tests are certified for installation in aircraft. The testing cells were impressive, soundproofed rooms, where engines ran at full throttle, while instrumentation measured their performance. The roar was deafening even through the heavy soundproofing. Test engineers monitored gauges and recorded data, ensuring every engine met strict quality standards. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.